The electrical contact resistance between two conductors in contact with each other does not depend on the nominal area of contact. It depends only on the mechanical force between two conductors apart from certain mechanical and electrical properties of the material of the two conductors. This is a key concept for understanding how electrical connections function. When terminating electrical wires, whether copper or aluminum, the primary factor ensuring a good connection is the mechanical force applied at the termination point. A greater mechanical force leads to low contact resistance, promoting better electrical conductivity. Firstly, consider the materials involved. Copper and aluminum have different electrical and mechanical properties. Copper is generally more conductive and ductile than aluminum. Aluminum tends to oxidize readily, forming a non-conductive layer of aluminum oxide on its surface. This oxide layer increases contact resistance if not properly addressed. Secondly, surface preparation is critical. For aluminum, it's essential to use an antioxidant compound specifically designed for aluminum connections. This compound helps to break down the aluminum oxide layer and prevent it from reforming, ensuring a good electrical contact. Copper, while less prone to oxidation, should still be clean and free of any corrosion or contaminants before termination. Thirdly, consider the termination method. Wire binding screw terminals are common, but proper technique is necessary. When using screw terminals, ensure the wire is properly sized for the terminal. Over-tightening can damage the wire or the terminal, reducing the mechanical force over time. Under-tightening results in insufficient contact force and higher resistance. Fourthly, torque specifications are crucial. Many electrical components and devices specify a torque value for screw terminals. Using a torque wrench to tighten the screws to the specified torque ensures consistent and proper mechanical force. Fifthly, consider the effects of temperature cycling. Electrical connections are subject to temperature changes due to ambient conditions and the current flowing through the conductors. Temperature cycling can cause expansion and contraction of the materials, potentially loosening connections over time. Periodically inspecting and retightening connections, especially in high current or high temperature applications, is a good practice. Sixthly, consider dissimilar metals. When connecting copper and aluminum wires, use connectors specifically designed for dissimilar metals. These connectors often incorporate a barrier compound that prevents galvanic corrosion, which can occur when dissimilar metals are in contact in the presence of an electrolyte. Seventhly, consider the environment. In corrosive environments such as coastal areas or industrial settings, use corrosion-resistant connectors and enclosures. These protect the connections from moisture and chemicals that can accelerate corrosion and increase contact resistance. Eighthly, consider the importance of proper wire stripping. When preparing the wire for termination, strip the insulation carefully to avoid nicking or damaging the conductor. Nicks can create points of high resistance and potential failure. Ninthly, consider the use of compression connectors. Compression connectors provide a reliable and secure connection by crimping the connector onto the wire with a specialized tool. The crimping process creates a high mechanical force between the connector and the wire, resulting in low contact resistance. Tenthly, consider the importance of regular inspection and maintenance. Electrical connections should be inspected regularly for signs of corrosion, looseness, or overheating. Any issues should be addressed promptly to prevent potential failures. 11thly, let us discuss about wire size and ampacity. Proper wire sizing is crucial to prevent overheating. Use the appropriate wire gauge for the anticipated current load, consulting the National Electrical Code, specifically Article 310.15 and related tables for ampacity ratings. 12thly, think about the National Electrical Code requirements. The National Electrical Code provides guidelines for proper wiring practices, including termination methods and torque requirements. Adhering to the NEC ensures safe and reliable electrical installations. 13thly, we should consider about voltage drop. Excessive voltage drop can occur if the wire is too small or the connections are poor. Use the appropriate wire size to minimize voltage drop and ensure proper equipment operation. 14thly, we need to think about the proper use of tools. Use the correct tools for stripping, cutting, and terminating wires. Using the wrong tools can damage the wire or the connection, compromising its reliability. 15thly, consider the impact of vibration. In applications where vibration is present, use connectors and termination methods that are resistant to loosening. Lock washers, lock nuts, and vibration-resistant connectors can help maintain a secure connection. 16thly, consider the use of terminal blocks. Terminal blocks provide a convenient and organized way to terminate multiple wires. They offer secure connections and facilitate easy troubleshooting and maintenance. 17thly, let us discuss about bonding and grounding. Proper bonding and grounding are essential for safety. Ensure that all metal enclosures and equipment are properly bonded and grounded to provide a low impedance path for fault currents. 18thly, we must consider about surge protection. Surge protection devices can protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Install surge protectors at the service entrance and at sensitive equipment locations. 19thly, think about the effects of harmonics. Harmonic currents can cause overheating and equipment malfunction. Use harmonic filters to mitigate the effects of harmonics in electrical systems. 20thly, consider the importance of load balancing. Balance the loads on each phase of the electrical system to minimize neutral currents and prevent overheating. 21stly, let us discuss about power quality. Monitor the power quality of the electrical system to identify and address issues such as voltage sags, swells, and transients. 22ndly, we must think about preventative maintenance. Implement a preventative maintenance program to inspect and test electrical equipment regularly. This can help identify and address potential problems before they lead to failures. 23rdly, we have to consider about infrared thermography. Use infrared thermography to scan electrical connections for hotspots. Hotspots indicate high resistance and potential failures. 24thly, we must consider about arc flash hazard. Be aware of the arc flash hazard when working on energized electrical equipment. Use appropriate personal protective equipment to protect yourself from arc flash injuries. 25thly, let us discuss about coordination studies. Perform coordination studies to ensure that overcurrent protective devices are properly coordinated to minimize downtime and prevent equipment damage. 26thly, we need to think about selective coordination. Selective coordination ensures that only the overcurrent device closest to the fault opens, minimizing the impact of the fault on the rest of the electrical system. 27thly, we have to talk about ground fault protection. Ground fault protection devices detect ground faults and quickly disconnect the power to prevent electrical shock hazards. 28thly, we must think about the safety interlocks. Use safety interlocks to prevent access to energized electrical equipment. Interlocks automatically disconnect the power when a door or panel is opened. 29thly, we should consider about labeling. Clearly label all electrical equipment and circuits to facilitate troubleshooting and maintenance. 30thly, we must consider about documentation. Maintain accurate documentation of the electrical system, including wiring diagrams, equipment specifications, and maintenance records. 31stly, let us talk about training. Provide adequate training to all personnel who work on electrical equipment. Training should cover safety procedures, proper work practices, and troubleshooting techniques. 32ndly, we must consider about the grounding electrode system. Ensure that the grounding electrode system is properly installed and maintained to provide a low impedance path to ground. 33rdly, let us think about the National Electrical Code Article 250. This article covers the requirements for grounding and bonding. 34thly, we should talk about the types of grounding electrodes. Common grounding electrodes include ground rods, ground plates, and metal water pipes. 35thly, we must think about the size of the grounding electrode conductor. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, consulting NEC Table 250.66. 36thly, we should discuss about the bonding jumpers. Bonding jumpers are used to connect metal enclosures and equipment to the grounding system. 37thly, let us think about the equipment grounding conductor. The equipment grounding conductor provides a low impedance path for fault currents to return to the source. 38thly, we must consider about the isolated ground. Isolated grounds are used to reduce electrical noise in sensitive electronic equipment circuits. 39thly, we should consider about the surge protective devices SPD. Surge protective devices are designed to protect electrical equipment from voltage surges. 40thly, let us talk about the types of SPD. SPD are available in various types, including hardwired SPD and plug-in SPD. 41stly, we should think about the location of SPD. SPD should be installed at the service entrance and at sensitive equipment locations. 42ndly, we must discuss about the ratings of SPD. SPD are rated by their surge current capacity and their voltage protection level. 43rdly, let us think about the harmonics mitigation. Harmonics are unwanted currents and voltages that can cause equipment malfunction. 44thly, we should talk about the harmonic filters. Harmonic filters are used to reduce the levels of harmonics in electrical systems. 45thly, we must consider about the types of harmonic filters. Harmonic filters are available in various types, including passive filters and active filters. 46thly, let us think about the power factor correction. Power factor correction improves the efficiency of the electrical system by reducing the amount of reactive power. 47thly, we should discuss about the power factor capacitors. Power factor capacitors are used to improve the power factor of electrical systems. 48thly, we must consider about the automatic power factor correction. Automatic power factor correction systems automatically adjust the amount of capacitance to maintain a desired power factor. In summary, when dealing with electrical connections, the mechanical force between the conductors is paramount. Proper surface preparation, correct termination techniques, adherence to torque specifications, and regular maintenance all contribute to ensuring reliable and safe electrical connections, whether using copper or aluminum wires. Understanding these factors is crucial for anyone working with electrical systems.